Let's look at a reference angle. Remember, the reference angle is an angle that connects to the x-axis from the origin. This is a reference angle. This right here is the reference angle, not the black, this red. It always connects straight to the x-axis. Okay, now let me clarify. This angle does connect to the x-axis, but I'm talking about a straight to it if you wanted to make an acute triangle. So this would be the reference angle here, and if you connected it to make a triangle, you would call this the reference triangle. So that there would be the reference triangle. It would be an acute right triangle. That would be a reference triangle. This is the reference angle because it connects the x-axis. Same thing, same concept here is on the next one. You can make a reference triangle by going like that, and this would be the reference angle. So here, this is the reference angle because it connects to the x-axis when you make your reference triangle. So that's just some vocabulary to use. These are up here, if you think about it. These are supplementary because they add up to 180, so that's why they go from there. This would be an addition. And so they're just showing you different ways of calculating what the values there are. The reason you subtract 180 because it's after 180, so if you take them away, you'd be left with what you got there. So it's just kind of a way to solve for each of these. All right, so first, it says sketch negative 150 degrees, then find its reference angle. Now, if you don't like working with negatives, if you remember from before, we could find something that's coterminal. If you add a whole circle, which is 360 degrees, you'll get something that'll give us the same value. When we add these, I'm going to get 210 degrees. So we could graph this one of two ways. So if we had to sketch this, and I wanted to find 210, I could think about it going this way, going from 0, that's 90. This is 180. This is 270. And this comes around and becomes 360 degrees. And so 210 would be just past the 80. It would be somewhere over here. Now this could be 210 degrees. Or if you didn't want to do it that way, you could have gone down from this direction and said negative 150. This is the same thing as negative 90 degrees here. And this is equivalent, if we went the other way, to negative 180 degrees. So these are equivalent to each other. And so we could have known that going this direction, we get negative 150 degrees. Or the way we did it the first time, going around this way, is 210 degrees. Either way, we get the same angle. So if we had to find the reference angle, what you do is you first make a reference triangle. All right, so I will connect this here. So you connect it to make an acute angle. And now we need to find out what is this value right here, the angle that connects from the origin to the x-axis. Well, it's the difference between 180 and 210, which means it would be 30 degrees in this scenario. That is the reference angle, and that's going to be very important for us moving forward. Here they have the same idea. They show it as 30 degrees after they went from going down below negative 150 degrees. Here's another one for 3 pi over 4. Now we're going to learn a trick in class to help you locate where these are found. These are positive, so we'll go starting on the right here at 0. We'd go up. This is pi over 2. This is 2 pi over 2, which reduces to just pi. This is 3 pi over 2. Now, as it concerns pi over 4s, you have a pi over 4 here, you have a pi over 4 here, you have a pi over 4 here, a pi over 4 here. This one's 1 pi over 4. This one's going to be 3 pi over 4. So the angle this time that we're looking for is going to be over here. Now, we could change this if you needed to degrees. Remember, this is just the same thing as 180, but there's a hand trick you're going to learn in class that will help us out. This is 3 pi over 4, which if I make an acute triangle out of this, my reference angle located right here, I forgot to draw this arrow here, this is 3 pi over 4. Going that way. Let me take that one away. Okay, what's left over here? This is 1 pi over 4. It would be the same thing as if we graphed it over here. So we're going to learn when we do it with radians, we'll always keep the denominator. Since it becomes a acute triangle, it'll always have a numerator of 1. So theta here is going to be 1 pi over 4. So I don't confuse people. Let me explain this further. If we had to find the reference angle of 7 pi over 4, the answer would be pi over 4. If we had to find it of 30 million pi over 4, the answer would be pi over 4. If we had to find the reference angle of negative 5 pi over 4, the answer will still be pi over 4. Whatever the denominator is, stays. So let's say it was 3 pi over 6. Well, it would simply become pi over 6. That was a bad one because it would reduce. But let me say if it was 5 pi over 6, if you had to find 5 pi over 6, its reference angle would be pi over 6. So all that happens when you do a reference angle of radians is the numerator disappears, unless you can reduce it. Then you would reduce first. So now you try this one.